Okay, review packet. Let's start with section 2A. Now, looking at these order pairs, we're going to determine if the domain. So the domain is the first number in each order pair. Make sure you write them in increasing order. So -2, -1, and 1. Range is the second number in the order pair. Also must be written in increasing order. So -2, 0, 2, and 3. Then we determine if the equation is a function or not. Well, we notice here that we have the domain of 1 going to two different range values, so that means that this is not a function. All right, looking at question number 2, our domain is 1, 2, 3, 4, and 5. Our range again is the second numbers in each order pair. So that's 1, 2, 5, 10, and 15. Now, we can look at this one way. I can look and see if each of these domains are individual or not. And that gives me yes, this is a function. Repeating the same process for for number 3. We get 15 fourths, 17 fourths, 15 and 17 is our domain, and our range happens to be the same thing. Look and make sure each domain value only goes to one unique range value. In this case it does, so yes, it is a function. Our domain for number 4 is -3, 3 halves, and 5. Our range values are -5, 2 fifths, and 3 halves. Determine if this is a function or not. Well, I see the first 2 points, -3 is going to 2 fifths and 3 fifths. Another way, instead of just looking at the points, you can also always do a quick mapping to determine if it's a function or not. So I'm going to illustrate this one with mapping. So -3 goes to 2 fifths, -3 goes to 3 halves. So right there I have two lines coming out of a single domain. So that tells me through mapping that no, this is not a function. Okay, for each of the following is a relation. So write the relation means you want to list the order pairs. So I'm just going to go down. Now the order pairs do not have to be in any special order, so I'm just going to write them in the order that I see them. So I'm translating each dot to the coordinates x, y. All right, then the domain, of course, is the first number of each order pair. This one does have to be written in increasing order. The range is the second number in each pair. Also written in increasing order. Then to determine if it's a function or not, I can either do the vertical line test from the graph, or I can look at the pairs like I did in examples 1, 2, 3, and 4. But no, this is not a function. Repeating the process for number 6, we have our relation is the point -2, 3, 0, 1, 2, -1, 3, -2. And then our domain would be the x values. So -2, 0, 2, and 3. Our range is our y values, which would be -2, -1, 1, and 3. Then testing with the vertical line test. Regardless where I draw this vertical line, it only goes through one point, so this is a function. Okay, to help kind of see this graph, I'm going to identify these key values on my graph, just so from where you're seeing it, I know I couldn't zoom in too well. So we got -5, 3. This is -2, -8. Up here at the top is 1 comma 9, and here at the bottom is 7 comma negative 9. Let me move those two bottom points so I can have room to write my domain. So our domain is x such that I ask myself, what's the smallest x value? What's the largest x value I have? And do I have any gaps in between? So my x such that x is -5, which is less than or equal to x, which is less than or equal to y. Range, we look at the lowest down to highest up. So y is y such that -9 is less than or equal to y, which is less than or equal to 9. Now to figure out if it's a function, do the vertical line test, and it passed, so yes, it is a function. Okay, number 14, here my vertex is at the point 0, 2, and then my domain is x such that x is the element of all real numbers, because with hyperbola it keeps going up and out, I go from -infinity to infinity on my x-axis. My range, my lowest y value is this 2 value, and then my graph continues going up forever and ever since this is concave up graph. So therefore my range is y such that y is greater than or equal to 2. And yes, it passes the vertical line test, so this is also a function. All right, so let's identify these key values on the circle. This is 0, -2. We got 2, 0, 0, 2, and -2, 0. So what is our domain? Well, our smallest x value is -2. And our largest x value is 2. And then I have all x values in between. So I say x such that -2 is less than or equal to x, which is less than or equal to 2. Now my range, my lowest down my graph goes is -2. The highest up my graph goes is 2. And I've connected all the lines in between. So range is y such that -2 is less than or equal to y, which is less than or equal to 2. This fails the vertical line test, and so it's not a function. Identify key values. This is the point 1, -1. So my domain, my farthest to the left my graph goes is -infinity. Farthest to the right it goes is infinity. And so my range is all real numbers. For my domain is all real numbers. For my range, the lowest down it goes is -1. The highest up it goes is infinity. It connects, the line is connected in between all of that. So therefore, y is such that y is greater than or equal to -1. Yes, it passed the vertical line test. So yes, it is a function. Okay, 24 here. This point is the point 0, 2. This is 2, 0. And here at the bottom, we have the point 0, -2. So find my domain. What's the farthest left I go? Well, 0. I do it twice, but farthest left I go is 0. Farthest right is 2. So my domain is x such that 0 is less than or equal to x, which is less than or equal to 2, because I have that smooth line connecting those dots and no gaps or jumps in between my graphs. My range, lowest down is -2, and highest up I go is 2, so therefore my range is between -2 and 2. It fails the vertical line test, so this is not a function. Okay, determine if the mapping is a function or not a function. Well, A is not a function because, as you can see, the domain value of 1 goes to 2 different range values, 3 and 4 in this case. So since at least one domain value is mapped onto more than one range value, it is not a function. And B, on the other hand, all the domain values go to exactly one range value, so yes, it is a function. Okay, so explanation, this is a function since every domain value is mapped onto exactly one range value. Number 3, we're given the mapping. We're asked to find the domain. So just write it in increasing order, -5, 3, and 1. The range, and write it in increasing order, -4, -2, 0, 2, 4. Is it a function or not? Well, I can look here at the 0 and the 1 and -5 to see no, it's not a function. You're also asked to graph the relation, so you just plot each point by the mapping. So 3 is mapped onto 0, so that's the point 3, comma 0. -5 is mapped onto 4, so that's common -5, 4. And then -5 is mapped onto -4. So you can see here very clearly by the vertical line test, this is also not a function. Okay, example B, our domain -3, -1, 0, 1, and 3. Our range -1, 1, and 6. It is a function because each domain value is going to one and only one range value. So mapping this, -1 goes to 1, 0 goes to -1, -3 maps to 6, and 3 also maps to 6. Do not connect the dots to form a parabola. This point is only those values. Okay, section B, we're asked to evaluate some functions. So if I want to find h of 6, I just replace every t with 6, simplify it down, and I end up with 11. And g of 1, replace every a with 1, simplify down. I get 3 to the first power, which is the same as just the number 3. So g of 1 is 3. W and -7, replace x every t with -7, simplify down. W and -7 is 15. Number 4, g of -6, replace every x with -6. Simplify down, I get g of -6 is equal to -21. All right, h of 4, replace every n with 4. 4 squared is 16. 16 times -2 is -32. Plus 4 gives us a -28. So h of 4 is -28. Number 6, h of -2. Replace every t with -2. Simplify down. Do the exponent first, so I have to simplify the exponent completely down, and I end up with -2 times a 5, which is just simply -10. So h of -2 is -10. F of -8, replace every x with -8. Combine like terms and simplify down. F of -8 is equal to 88. P of -1, replace every a with -1. So I get -4 raised to the -3 power. So that becomes we move that -4 down to the bottom and do our power to the cubed. So that becomes P of 1 is equal to -1/64. Okay, P of t minus 2, replace every t with t minus 2. Do my distributive property, combine like terms. I end up with P of t minus 2 is 4t minus 13. Okay, 10, replace every a with 2a. Simplify down, g of 2a is 8a. Number 11, replace every n with 3n. Multiply, and I end up with w of 3n is 12n plus 2. And number 12, replace every a with a plus 4, combine like terms, a plus 7. So w of a plus 4 is equal to a plus 7. H of x plus 2, replace every x with x plus 2, distribute the property of the 4, distribute the 4, gives me a 4x plus 8. Combine like terms, 4x plus 6 is what h of x plus 2 is equal to. K of a minus 2, replace every a with a minus 2, do my distributive property in my exponents, combine like terms in the exponent, and that's the farthest I can go. So k of a minus 2 is negative 4 to the 3a minus 4 power. G of negative 4n, replace every n with negative 4n. All right, distribute the cube to each term. Negative 4 cubed is a negative 64. N cubed. Okay, minus 5 times squaring the negative 4n is 16n squared. Multiply, I get negative 64n to the n cubed minus 80n squared. So g of negative 4n is equal to negative 64n cubed minus 80n squared. So number 16, f of n squared, replace every n with n squared. I get n to the 4th minus 2n squared, no like terms, so I'm done. All right, 17, p of x minus 4. I replace every a with x minus 4, cubed minus 5. So this x minus 4 cubed is x minus 4 times x minus 4 times x minus 4. Please do not just distribute the cube to each term. I'm going to start by doing the full method for the first two parentheses. Combining those like terms, I end up with x squared minus 8x plus 16 times x minus 4 minus 5. Now I'm going to distribute the x to each term in the first parentheses. And now I'm going to distribute the negative 4 to each term in the first parentheses. And I still have this minus 5. Don't forget your extra term there. Now I'm going to combine all like terms. Gives me an x cubed, negative 12x squared, plus a 48x, minus a 69. Number 18, h of 4 plus t gives me 2 times 3 to the 4 plus t plus 3 power. So 2 times 3 to the t plus 7 power, and as far as you can go. Simplify it as far as it'll go. Okay, for our next example, we're going to look at our domain and range. So it asks us to define our domain algebraically. So looking at A, I have y is equal to 5x plus 3. I check and see, do I have x in the denominator of a fraction? No. Do I have x underneath a even radical? No. Therefore, my domain is all real numbers. Then it asks us to sketch the graph. So I'm going to use my calculator, and I'm just tracing values on my calculator and giving some points. And then I'm going to use my ruler to help me draw a straight line connecting these points because I should have a linear function. Arrows on each end. So my range, farthest down I go is negative infinity. The highest up I go is positive infinity. Therefore, my range is all real numbers. Okay, looking at B, we have y is equal to negative 7x minus 4. And so what I'm going to look at first here is no x in the denominator of a fraction, and x is not an even radical, so therefore my domain is x such that x is an element of the real numbers. Then I'm going to sketch this graph. I'm using my calculator and getting some points off of my calculator. Then I'm going to use my ruler, connect my dots. And this is what my graph should look like. So my lowest y value is negative infinity. My highest y value is negative infinity. Therefore, my range is the y such that y is an element of the real numbers. On C, I told you do not have to do this vertical one. So let's go on to D, which is our parabola unit. So all these are the parabola questions. So in D, we get y is equal to x squared. So I ask myself, no x underneath the denominator, no x in the underneath the even radical, therefore my domain is all real numbers. Sketch this graph using my calculator, plotting a few points here. Identify my lowest y value or my lowest point. So my vertex is at 0, 0. So my range, my y value starts at 0 and goes up. So therefore, my range is y such that y is greater than or equal to 0. Looking at E, y is equal to 2x squared plus 1. So my domain, again, is x such that x element of the real numbers. That's going to be for all parabolas that we're looking at here. Domain is always x of real numbers, because if you have a parabola, you never have x in the denominator of a fraction. You never have x underneath an even radical. Then I'm using my calculator to sketch some points. Identify my vertex. From my graph, I can use my calculate minimum value to find that actual vertex, but that's one thing we do want to find. And it's easy to see from this graph, my vertex is at the point 0, 1. And so my range, my farthest down on my y I go is 1, and then I'm up from there. So therefore my range is y such that y is greater than or equal to 1. You can also look at the parabola itself to help you figure out if you're having problems noting if you should have greater than or equal to or less than or equal to in your range. Well, if your function is concave up, then your parabola range will be greater than or equal to. So that's the y value of vertex. If it's concave down, it will be less than or equal to the y value of the vertex. So I'm going to do F with this new knowledge. So again, since it's a parabola and I'm not dividing, I don't have x in the denominator of a fraction, and I don't have x in the underneath a square root, I know my domain is x such that x is an element of the real numbers. Now this parabola is a concave up parabola, so all I need to do is figure out my vertex. So remember, I can find the x value vertex by taking opposite of b over 2a, which gives us 1, plugging that into my function in place of every x, which gives us 4. So I know my range is y such that y is greater than or equal to 4. Since it's concave up, I use greater than or equal to. Now let's graph this and check and see if the graph agrees with what we just found algebraically. And there's our graph. So yes, my range is greater than or equal to 4. I will never require you on your this test to figure out the range algebraically, but that's a good way to check yourself if you're not confident if you plugged it into your calculator correctly. Okay, g, y is equal to 4 minus x squared. This is a concave down parabola. So I know my range is going to be less than or equal to my y of my vertex. And now my domain is going to be all real numbers since it's a parabola, and it does not pass the 2 test. There's no x in the denominator, there's no x underneath an even radical. So graphing this fairly quickly using my calculator. And it's very easy to see that my range is y such that y is less than or equal to 4. H, y is equal to -1 plus 2x minus x squared. This is a concave down graph, so my range is going to be less than or equal to. Okay, it is a quadratic, so my domain is going to be x such that x is the element of the real numbers. Using my calculator, let's get the graph of this. Plot a few points. Use my calculate maximum to find our vertex, which is 1, 0. So therefore my range is y such that y is less than or equal to 0. So we talked about linear function, now quadratics. Our third type will be radicals. Y is equal to the square root of x plus 9. Now when you have a radical, you take whatever that's underneath the radical, and it must be greater than or equal to 0 for our domain. So you set the whatever underneath the radical, set it greater than or equal to 0, solve it, and that gives you your domain. So x such that x is greater than or equal to -9. I'm going to use my calculator. I'm going to sketch this graph. Now, I'm going to change my scale a little bit. I'm going to count by twos. So every line is worth 2 points instead of one over. That's just so I can fit a little bit more into this graph. I'm going to label this so you can see. You are not required to label it, but just to help you with my change in scale to figure out the points plotted. And I'm going to label that first value because it's going to help me find my domain and range. Well, my range. Okay, so I have a graph that looks like this. And so my smallest y value is 0, and it goes up from there. So my range is y such that y is greater than or equal to 0. J, y is equal to the square root of 3x minus 4. So again, radicals, you take what's underneath the radical and set it greater than or equal to 0 to find your domain. Solve this mini equation. And x is greater than or equal to 4/3. So therefore my domain is x such that x is greater than or equal to 4/3. Then use my calculator to sketch the points, starting with 4/3 as my x value. And then since this is my radical will always be greater than or equal to 0. So that's going to be my range, as long as I'm not adding or subtracting anything to the equation. So looking at my graph, I can easily see that yes, my range is y such that y is greater than or equal to 0. Okay, y is equal to the square root of x squared minus 4. Start the same way, set what's underneath the radical so that it's greater than or equal to 0. This is the difference of squares, so it factors to x minus 2 times x plus 2. Now, when I have two terms that it's greater than or equal to 0, I need to do a sign diagram. When I have a quadratic underneath the radical, always do a sign diagram, quadratic underneath the radical. Plugging values in, I see I'm plugging in -3. End up with a positive value. Plugging in 0, get negative times positive, which is negative. Plugging in 3, I end up with positive. So I want to know when it's greater than or equal to 0, so it's in this red areas here. So that makes my domain x such that x is less than or equal to -2, or x is greater than or equal to 2. Then we'll use our calculator to make a quick sketch of this graph. And then we'll figure out the range from the graph. Our smallest y value is 0, and our highest y value is infinity. So range is y such that y is greater than or equal to 0. All right, y is equal to the square root of 4 minus x squared. So it's going to start the same way. 4 minus x squared needs to be greater than or equal to 0. So I'm going to do difference of squares. And then a sign diagram. Let me show all the steps on this instead of just going out. So that gives us 2 minus x is equal to 0. So negative x equals -2, x equals 2. And here we end up with x is equal to -2. So sign diagram is again 2 and -2. Doing my test value of -3. I end up with negative. When I plug in 2, I get positive. 0, I plug in. When I plug in 0, I get positive. When I plug in 3, I also get negative. So I want to know when this is greater than or equal to 0. Well, that's between the -2 and the 2. So therefore, my domain is x such that -2 is less than or equal to x, which is less than or equal to 2, because I want it between -2 and 2. Then I'm going to use my calculator, make a quick sketch of the graph. And then I look at the lowest down the graph goes, which is 0, the highest up it goes is 2. So therefore my range is going to be from 0, in between 0 and 2. So y such that 0 is less than or equal to y, which is less than or equal to 2. Okay, now let's look at how we do it with rational functions. So m, we have y or f of x is equal to 1 over 7 minus x. So the key is we cannot divide by 0 for our domain. So we set whatever's in our denominator not equal to 0. And I end up with x cannot equal 7. So my domain would be x such that x is not equal to 7. Graphically, when I have a domain is not equal to 7, that means at y equals 7, I'm going to have, and again, I'm changing my scale to counting by 2s. A vertical asymptote. So let me draw that vertical asymptote where my domain does not exist. It needs to be drawn on your graph dash line. Okay, to figure out my range, I look at my degree on the top and the degree on the bottom. Since the degree on the top is less than the degree on bottom, my range is y such that y is not equal to 0. So I have a horizontal asymptote on the x-axis. Get myself some room on my graph. The rest of the graph is used for my graphing calculator, so I just graph the function. Then on each piece, I need to find 3 points on each piece, so I'm just going to do trace until I find 3 points, and I'm going to do a quick sketch of the graph. Looking at the graph, yes, my range is everything, my domain is everything except 7, and yes, my range is all above and all below the 0, so it's not equal to 0. Okay, for n, f of x is equal to 6 divided by x plus 2. So domain, we know the denominator x plus 2 cannot equal 0, so therefore x cannot equal negative 2. So domain is x such that x is not equal to negative 2. Draw a horizontal asymptote at negative 2. Okay, to figure out our range, we look at the degree of the top divided by the degree of the bottom. So this is degree 0, and x plus 2 is the degree 1 equation. And so therefore my range is y such that y cannot equal 0. Then I use my graphing calculator to make a quick sketch, doing points on each side of the graph. Okay, I'm going to add a few problems here. I told you to mark out those 3 on your paper. Let's add a couple. So let's say f of x is equal to x plus 2 divided by x minus 1. So our domain here is where the denominator, x minus 1, cannot equal 0, so x cannot equal 1. So x such that x is not equal to 1. So at 1, we have a vertical asymptote. Now our range, we're going to look at our degree of the top and our degree of the bottom. So our degree of the top, that's a degree 1 equation because it's x plus 2. And then our bottom equation, x minus 1, is also a degree 1 equation. So when the degrees are equal to each other, so we divide the leading coefficients. So the number in front of the x term is 1 divided by 1. So y cannot equal 1. So our range is y such that y is not equal to 1. And so we have a horizontal asymptote here at y of 1. So we need to draw that in on our graph. Then I'll use my graphing calculator, get 3 points from each side, and make a quick sketch of the graph. All right, let's add one more equation. Let's make this, I don't want to use p because I'm going to use p on the next page, so a of a. F of x is equal to x squared minus 4 divided by x plus 1. So our domain starts out the same way. I take whatever my denominator is, which is x plus 1, and set it not equal to 0. Solve that little equation, x cannot equal -1. So my domain is x such that x is not equal to -1, and that means I have at -1, I have a vertical asymptote. To figure out my range, I look at the degree of the top, divide by the degree of the bottom. So I have x on the top of my fraction, I have x squared minus 4. So that is a degree 2 equation. On bottom, I have x plus 1, so that's a degree 1 equation. Since my degree on top is greater than my degree on bottom, we have all real numbers for our range. And then I'm going to use my graphing calculator to get the at least 3 points from each side. You'll probably have to get a little bit more to get a good idea of what this graph looks like. So then we use a graphing calculator and make a quick sketch. Okay, P, we have y is equal to 2 divided by the square root of 2x minus 5. So here we have x underneath underneath a radical and in the denominator of a fraction. So then you take whatever is underneath that radical and in the denominator and set it greater than 0. So our domain is x such that x is greater than 5/2. So since this is also in the denominator, you can think of it like we have a vertical asymptote at 5/2. I'm not requiring you draw a vertical asymptote at this point, but you can because the graph goes infinitely close to it, but it never actually reaches the 5/2. So then I'm going to use my calculator and get some other points, and I'm going to make a quick sketch of this graph. And since I can tell from my graph that it gets infinitely close to 0 but never actually reaches 0, or you can look at the equation, that fraction can never ever equal 0, I know my range is y such that y is greater than or equal to 0. All right, in our last example Q, y is equal to x divided by x plus 1. So I take my denominator, x plus 1, and set it greater than 0. Gives me x is greater than -1. So there is something like an asymptote at -1. It's not actually an asymptote, but you'll notice it'll show up kind of like one on my graph. But my domain is x such that x is greater than -1. And then this fraction, on the other hand, I can keep getting x values and y values. So I'm going to use my calculator to help me get a good idea what this graph looks like. So by looking at our graph here, we can see our range is y such that y is all real numbers. It keeps going down, it keeps going up. So it's elements of the real number lines.